Welcome to the channel. So during this video we are going to discuss some theoretical details about model context protocol, which is required to build a MCP server. Because during the next video I'm going to discuss how to implement MCP server using Java and Spring Boot. So here we will discuss all what is required to build the MCP server. So let's see what is MCPs. So the MCP, the Model Context Protocol. So that's an open source standard for connecting AI applications to external systems. So this open source standard actually developed by Anthropic in 2024, but later they handed it over, like in 2025, they handed it over to the Linux Foundation. So let's see uh, why we wanted something called model context protocol first. So I think it's easier to understand why we wanted the MCP, or why we wanted a concept called MCP, by comparing before how things were handled before MCP and after the MCP, right? So now if we look at the left hand side of this diagram, so this is how we connect our applications with AI before the MCP. So during this particular phase, so we had to write custom connectors. That means our application had to write custom connectors to connect to all the external systems to get the required information, which is that needs to be passed to the LLM, or the information required by LLM can be fetched through our application by talking to these external services. So this model had a major drawback. The problem was called M by N problem. So what is this M by N problem? So like if we have an application, and if we have to connect to M number of services to fetch or read write information. Then if we have n number of AI models to support, so then what happens is our application need to maintain m times n connectors, so which was a big headache, and it was a very tedious task to maintain all these connectors. So every time when there are application changes, so we have to manage all these within the application itself. Big overhead. So therefore, so we wanted something to eliminate this dependency in our application, so that our application can have a single unified connectivity across all these services. So that's why the concept of MCP was introduced. So now when you compare the left side and the right side, you can see now our application always has a single connection, and the model context protocol maintains all the connectivities to the external systems. So this way, our application is more independent and more easier to manage and maintain. So that's the idea behind introducing this concept of model control protocol. So now let's see, in order to like when we look at the model context protocol definition, before coming to much more details, I need to show the documentation on the MCP. So which should be always the handbook for finding any detailed information about this protocol definition. So I will first show it and then we'll come back to this. So if you look at this website, model context protocol.io docs, so this will contain all the information required around about this protocol, and this has a lot of details, but we can't discuss all these details here, but I'm going to discuss all what is required to implement MCP server using Java and Spring Boot during this particular session. So once you learn all these important information and the important points of the protocol, then we can easily move to build a MCP server smoothly and quickly. So uh, keep a note on this. So this is a mandatory thing for anyone who wants to learn about the MCP. So we'll go back to the our presentation. Now, here with the as I told you earlier, so there are a lot of things around this MCP, the protocol, but I'm going to only discuss what is required for our purpose. So I think you need to understand these 4 points. So let's take you one by one. So the first important point is MCP, according to these all from the definition of the protocol, according to the definition of this protocol, it follows a client server architecture. So that means there should be a client and a server. That means MCP client and a MCP server. So who are the, or what are the roles in this particular use case, right? So there are actually three important participants in the definition, according to the definition of the MCP. That is the MCP host or the host application, and the MCP client and the MCP server. So we will go to these in bit more detail, but I'm going to just give you a introduction, so you can keep an idea in your mind what we are going to discuss next. So then the next most important thing on this protocol is the communication protocol used by this MCP protocol. So that is the JSON RPC2. So then the other most important thing is, according to the definition of MCP, we need to understand three core MCP server features. So that is tools, resources, and prompts. We'll look at these one by one, but for the time being, just keep in mind there are four important things we need to understand. The first one, it is following the client server architecture, and there are three participants in this: the host application, MCP client, and the server. And the communication protocol it uses is JSON RPC2, and there's something called primitives, which is actually tools, resources, and prompts. So let's look at these four items in detail now. So the first point we wanted to discuss, the MCP follows a client server architecture. So now we all know what is client server architecture. So there is a client and there is a server, but other than the client and the server, there is one more additional participants in this definition, that is called the host application. So host application means, like for example, like we know that we have the GitHub Copilot in VS Code. Like let's say we open the VS Code, and in the VS Code we open the GitHub Copilot, and we can communicate with the Copilot and we can ask questions. So then the GitHub Copilot is one example for MCP host. So similarly, there are some other AI clients, like for example, Cloud Desktop. So Cloud Desktop is also a MCP host application. Or we can consider any other application, like for example, let's say we have some other custom chat application, a chatbot, which supports integrating MCP. So then that custom application also can be considered as MCP host. We will see what's the role of this host in more detail in the next slides. But for the time being, just keep in mind, okay, so the host is there, and the client and server, obviously you can understand, I don't need to explain much in detail, but the most important thing here is the MCP client always sits inside the host. So when we want to connect to a MCP server, so we don't need to explicitly create a MCP client by ourselves, because the MCP host has the capability to create its own client to connect to a server. So therefore, we don't need to go and create a custom MCP client in order to connect to a MCP server. So the host application has the capability to create its own clients. So that's another important point. So then the next participant is the MCP server. So when we consider this server, server can be locally lived or remotely lived. So that means it can be it can be inside your machine itself, or it can be somewhere on the internet hosted, and we can connect to that. So that is the idea about all these three participants, and what sort of basic role that they perform. Okay. Okay, now we discuss the out of the four important points of the model context protocol definition. So the first one was follows a client server architecture, and the second one was there were three participants. So we discussed those 2 points in bit more detail, and now let's see what is the communication protocol that the MCP server is using according to the definition. Now we know that in any protocol, so they need some sort of communication, some sort of protocol for the communication. Now, according to the MCP definition, so we this MCP any MCP client and a server must use JSON RPC2 protocol for messaging between the client and the server. So what is the now I'm not going to discuss detail about the JSON RPC2 protocol, but if you want, you can go and find more details around it. But the basic idea of the JSON RPC2 is, so it's a it's kind of it's more focusing on invoking remote functions. So it's not like the http always the restful, like for example, if we compare this with restful http apis, so they focus more on a resource and accessing a resource using the URI, and then there are get, post, delete, all these kind of methods. But with the JSON RPC2, we more focus on invoking a remote procedure, and we always call a single endpoint with the post or get method, and within the body we tell what is the remote procedure we want to call, and we pass the parameters required by this remote procedure. So it's the basic idea about this JSON RPC2, right? Like for example, let's say we have we want to call JSON RPC a remote procedure using JSON RPC2. So then we will make a call to a endpoint which is hosted somewhere with host slash RPC, for example, with the post method, and the method, the remote procedure we want to invoke is get product, and the parameters we want to pass to get the product is the product ID, for example. So that's JSON RPC2. So the important thing is, so the MCP client and the server must use JSON RPC2 for the communication purpose. Okay, so that's the third point. And then let's go to the last one, the primitives. So there's something, okay, so when we are going to implement a MCP server, so we have to mainly focus on exposing three main server features called tools, resources, and prompts. So if we look at what a tool is something that the AI can invoke to either read or write into a certain service. Like, for example, let's say a tool can be for reading from a database, or a tool can be available for updating a database. And the next primitive is the resource. Resources are mainly focusing on read only data. So then when we make a resource available over MCP server, the AI can access that particular resource, and then or the application can access that resource and provide the information on the resource when it talks to the AI within the context. So that is so mainly the most important thing is tool is for read and write, and resources are mainly for read only purpose. So then the prompts, obviously, we all know who already have some experience with AI. We all know what a prompt is. A prompt is something, some request that we send to the AI. So now, and we all know that the more efficient prompts, the more efficient response that we get from the AI model. So therefore, with the MCP servers, we can provide prompts or prompt templates which can be used by the user for efficiently handling or talking to the AI through our application. So that is about the primitives. So then now the four important points that you need to keep remember about this MCP definition is: first one is it is using the client server architecture. The second one is it has three participants: the host, MCP client, and the server. And then it is using the JSON RPC2 for messaging between MCP client and the server. And finally, we need to have idea around these three primitives that needs to be supported by MCP server tools, resources, and prompts. Okay, so now I hope you have a good understanding around the most important points of this protocol definition. Okay, let's go to the next step then. Now, when we take these MCP servers, so mainly we can classify MCP servers into two categories. So that is a local MCP server and a remote MCP server. What do you mean by a local MCP server? So let's have a look, right? So now a local MCP server means it's running in your machine with the application. So like when you take a MCP host application, like for example, let's say GitHub Copilot, we take the GitHub Copilot and we configure an MCP server within the GitHub Copilot, and then when we give the command to the host application to start the server, So the host application will start the MCP server as a sub process of the parent host applications process. So that's why I made a dotted line around this. So this is the MCP server, sorry, this is the MCP host application. So the host application the MCP host application, when we configure a server, when we issue the command to the host application to start the MCP server, MCP host will start the MCP server as a sub process. And how the host application can connect to the server, the host application will also initiate a client. So that is why I earlier mentioned that if we want to connect to a MCP server, we must use a host application which supports MCP. So when you use a host application that supports MCP, so then automatically the host application will create a client instance so that it can make a connection to the locally running MCP server or remotely running MCP server. It doesn't matter. The host application will always create a client instance. Now, the local MCP server, now I hope you understand the idea. So since the MCP server is running as a sub process in the same machine as the host application is running, so the client and the server can communicate using the standard input output as the communication channel. So that's the important thing you need to understand. So if it is a local MCP server, the host application will start the server as a sub process, and also the host application will create a client. And since both the client and the server running on the same machine, they can communicate over standard input output or standard IO as the communication channel, right? So now the next point we need to look at it, how we can connect to a remote MCP server. So let's have a look. Okay, so this is about the remote MCP server. So now a remote MCP server can live anywhere on the internet, and it has a single URI that we can connect to it over HTTP. So now what we have to do is, we have a host application, like for example, as I told you earlier, the GitHub Copilot on your VS Code, and we configure the URL of the remote MCP server in the GitHub Copilot on VS Code. And then when we ask GitHub Copilot to connect to the remote MCP server, then the host application will create a client and will make a connection to the server. So this is very high level, and that communication, the channel, the local one, we saw that okay, it is standard IO, but here we can't use standard IO because it is not on the same physical machine. So it is the communication channel here is actually over streamable HTTP. That is called streamable HTTP. So that's the important point you need to understand. So that's so if it is a local, the communication channel between the MCP server and the client is standard IO, but here it is streamable HTTP. Okay, I think now we discuss about the local MCP server and the remote MCP server, and let's take a example and see what is how we can connect a host application to a local MCP server and a remote MCP server, so that you can understand these theories in bit more detail. Okay, let's go to our example. Okay. So before going to the example, again, I want to emphasize the importance of referencing this, the definition of the model context protocol. So this is very important. So whenever you want to find a bit more details about this MCP, always make sure that you keep this handy and you get used to this documentation, because that's really, really important. Okay, because during this exercise, I'm going to use some of the information given on this definition, right? So now, since I'm going to show you how to connect to these local and the remote MCP servers. So I'm going to use the same example that is described on this documentation, but this documentation is using Cloud Desktop as the host application, but I'm going to use the VS Code Copilot as the host application, right? So now here they are using one MCP server called server file system, which will allow the AI applications, or which will allow the AI models to access our local file system. So let's use the same thing, and let's try to configure this as a local MCP server on VS Code. So I'll open VS Code. Now, when you go to VS Code, doesn't matter whatever the repository you have, right? So now let's see how we can configure. To configure, so to configure the MCP servers, you need to go to the command palette here, and then on the command palette, if you type MCP, so you can see that the workspace folder configuration and user configuration. If you go to the workspace folder configuration, whatever the configuration that you created here will only be a scope to this particular workspace or this particular repository. And if you go to the user configuration, it will be available for all the repositories. So but for this example, I'll go to the workspace configuration. So it says, okay, there's nothing at the moment. That means nothing configured. So I'll hit create file. So so now if you look at carefully, so under .vs code, the hidden folder, it created something called mcp.json, a JSON file with the name MCP. Now let's open the empty JSON structure, and since I want to configure MCP servers, so we need to give these servers, right? And then the Copilot suggests, I took that suggestion, because I can just replace the things. So since I'm going to configure a MCP server to access my local file system, I'll give a sensible name there, my local FS, my local FS. And let's go and see what's the command. So the command is npx, and these are the arguments we need to provide. Okay, we copy these arguments, and let's say, okay, the command is not Python, it should be npx, and let's replace these ones. Okay, so we gave, and model context protocol. uh, Okay, so since this MCP server is going to access a local file system, so we need to give what folders in the local file system can be accessed. So that is what these other arguments is. Okay, let's go to clear and cd. So I'm going to give permission to access my desktop. Okay, let's see what's in my desktop. Okay, so there is only one JSON file, and this is the path. Okay, I'll copy this path quickly. Yep, and I'll give this path here, so it can access my desktop. And or as I'm only going to give permission to access my desktop, I'll remove the others, and I'll save this file. So if you look at this, so there are three arguments that we have provided: y minus y, which is required, by the MCP server, and this is the MCP server, and this is the folder that I am giving permission to access on my file system. Okay, now once you configure all, so the automatically a button appears called start. Now we can click the start, so the host application can start the MCP server and start the MCP client and get the communication link connected between the MCP client and the server. As I told you earlier, so the host application will create a client instance so that it can connect to the MCP server. Okay, so let's click start, and it says running. Now since it is running, now let's go to the AI and ask something, so the AI can come through the MCP server and do the task for us, right? So let's say, can you list me the files on my desktop? Okay, so now since I asked the question to the AI model, the AI model should ideally use my MCP server, which allows it to access my local file system. So it is saying that, okay, allow reading external directory because desktop is outside the current folder. The current folder is this. So let's say allow. So it should now read my, okay, the files on your desktop are test.json. Only one file, that's right? So if I show you here, this is my desktop, and if I list files, only one file is there, test.json, and successfully it made that file here, listed that file here. So all good. All right, so this is about how you can configure a local MCP server and how you can ask the host application to start, restart, stop the MCP server, and how the host application create a client, MCP client, and made the connection to the MCP server via standard IO. Right. So now this is the local. Let's look at a quick example on how we can configure a remote one as well. Okay. So we'll configure another one. We can configure more than one. So this is, I'm going to connect to a MCP server called DeepWiki running on the internet. So I'll name it as a Deep Wiki. Right. So since this is a remote one, so we don't need to provide the command to start it locally. It is already running somewhere. We just need to connect to that using the URL. So we will provide the URL, and we will give the URL. So let me copy the URL. Okay, so this is the DeepWiki MCP server URL. Okay, so now that's also configured. We don't need to do anything. Now see, it's also now the host application giving us the option to start the MCP server. Here actually it is not going to start the MCP server. It's already started and running somewhere. So when we hit the start button here, what the host application, the VS Code will do, the VS Code will create a MCP client instance, and it will make a connection from the client instance to the remotely running server instance. So let's say start. If nothing wrong, it should ideally, yeah. So it connected, and it says, oh, there are 3 tools available here. So now let's see, I want to use something here, right? So let's say, what is this quick, have a quick look on this DeepWiki. So if we go to the DeepWiki, so this is what DeepWiki called, and the MCP supports reading all these repositories. Now, let's say Microsoft Playwright. Let's go here, and let's say I want to find key properties of this the Playwright framework. Okay, so then let's go and ask the AI, can you tell me the key properties of key properties of Playwright framework. And if we want the AI not to think about many different things, but just to focus on one thing and give us the information. So then we what we can do is, okay, we can ask the AI to focus on our deep wiki MCP server. So we can hashtag it deep wiki, right? So we can say deep wiki, uh, not hash deep wiki, right? So deep, so we tell, so by hashtagging, so we tell the AI focus on this guy and get the information from that. So let's say okay, we hit and let's give couple of seconds. It should yeah. So now this is the question it is going to ask. So what's the question? What are the key properties of the Playwright framework and repository name? Microsoft Playwright. And it is asking our permission. Yes, we'll give the permission. And see, it is using the ask question tool that is available here. So now it is running. So let's see what are the, it should give the information from that deep wiki documentation, right? So see that key capabilities, cross browser support, multi-language support, these. So those are cross browser, multi-language, cross browser, all these coming from here. So the information it read from here. So that's what it does. So now I think we understand how we can configure a host application to connect to a locally running MCP server and a remotely running MCP server. So now, before going back to the presentation, I want to quickly introduce you to another application that we can use as a host application, or rather it is it's purposely created for testing and debugging MCP servers. So let's go back to our the protocol definition. Now if you go to this one, so see that developer tools in MCP Inspector. So when you go to this MCP Inspector, this is a very important tool that we can use for testing MCP servers while we are building it. So now this is another host application we can consider as another host application. Now if you want to run this MCP Inspector, what you need to do is you need to install the Node.js, and once you install the Node.js, you can take this command and you can run that command on your terminal. Now if I run this command on my terminal, it should open a UI which gives the facility to connect to MCP servers, right? So that means it should give the interface of the host application for me to connect to a remotely running server or locally running server. So just like what we did on the VS Code, now it says open in the browser. If I go here, now see that it has opened a browser here. All right. So and see that we can use the standard IO. So that means for connecting to a locally running MCP server, or we can use streamable HTTP for using for a remotely running MCP server. Now if I want to connect to the remotely running DeepWiki MCP server, so streamable HTTP and select, and we say connect. So see that it connected. And if we look at the developer tools for here, see that we'll say reconnect. So we get see that it has a bunch of information, and these are really important. And see MCP protocol stuff, and if you go to the console and see that it gives some information, right? And if we want to find what tools available here, and if we click the tools and list tools, and see that it says there are three tools: read wiki contents, ask question. Okay, so this is the whole architecture what we discussed so far. So we have our host application. Host application can initialize connection with the remote MCP server or local MCP server. For for every MCP server, host application will create individual client, and for this remote MCP server, host application creates a client and makes a connection. And if there are two locally running MCP servers, each MCP server will have its own client. So this is the whole architecture that we discussed. Okay, so then I think that's the end of the session, and that's what we are going to discuss during this session. I think now you had a very good understanding about all these basic concepts which is required to start developing MCP servers. So let's meet in the next session on how we can develop MCP server with Java and Spring Boot.